Hello folks, we come to the miscellaneous exercise of chapter 7. This is our part 3 video. In the previous part we saw that huge problem of selecting a committee. Now we are coming to this problem number 4. Let's see what it says. Problem number 4 reads, in the different permutations of the letter of the word examination listed in a dictionary, how many words are there in the list before the first word starting with E? So they will give you any one alphabet and how many words are there before that. That is what the question is. They say to find out all the words which are there before E in the dictionary. So let's analyze the word, okay, and then let's try to find out the answer for it. This word examination is made up of two A. There are two A over here. Then there is one E. There is two I's. Then there is one M. We are going in alphabetic order. There is one M. There is two N, one O is there, one T is there, and one X is there. So that's a dictionary order. They ask us to find out all the words which come before E. So automatically they are indirectly asking us to find out all the words which is starting from A. That is the question. The question says indirectly what they are, because there is only A which is there before E. So indirectly what they are asking is find out all the words which are starting with A. So we are basically going to look at all the words which are starting with A. So what we do is, since we are going to look at all these, the first alphabet A is fixed. So we are only bothered about the number that comes after A. So after A what happens? After A we are having, this is 11, it's 11 alphabets. So we have to fill 10 places. We have 10 places to fill. With what? You have to fill the 10 places with 1 A, 1 E, 2 I, 1 M, 2 N, 1 O, 1 T, 1 X. We know it. There's no problem. We know when we form words, if at all there's a repetition, we just have to count the total number and we just write the number of permutation that happens from that number divided by whatever repetitions are there. So here, because there are 10 places, we will have 10 factorial, and repetitions, whatever, wherever it is, that will account for by dividing it in the denominator. So that many words will be there, that is before E in the dictionary. This is what is going to come up. Had they asked us anything else, every time we will do this. Suppose if they ask us a later alphabet. So suppose if they ask an alphabet like M. So find out all the alphabets starting with A. Then find out all the alphabets that starting with E. Then find out all the alphabets starting with I. Add them together. So you will get the total number of words. So this is a standard question, this dictionary problem. This is how you do it. So let's write it down. We'll say that here, in order to find out words before E in the dictionary, it is enough to find all words starting with A. For such a word, first alphabet A is fixed. We only have to find the number of a number of ways in which remaining 10 alphabets are placed. There are 2 I's, 2 N's also. So required number of words is, because we know that we have to look out for 10, there are 10 alphabets basically. First one A we have fixed, so we have 10 alphabets, so 10 factorial. by repeats. So that is 2 factorial by 2 factorial. If you want, you can divide it and get the answer. I don't know, 10 factorial, once upon a time we had by hearted it. I don't remember it, but I can always take up the number. I don't know, I have written it somewhere and kept. That I will quickly take. 36288800. 36288800. And then this is 2 and 2, so that's 4. So let's have the 4 cancelled. 4 9s are 36, cannot go, so 7 times 28, 2 times 8, that's it. This is the number. 907200 is the number of words in the dictionary before E when we look out for this kind of placement. That is our problem number 4. Let's move to the problem number 5. What does it say? How many 6-digit numbers can be formed from the digits 0, 1, 3, stay on the board, 0, 1, 3, 5, 7, 9, which are divisible by 10 and no digit is repeated? 2 cases, 2 conditions. One is that you are using these numbers, 0, 1, 3, 5, 7, 9, these are the digits that you are using. You have to form a 6-digit number. It has to be divisible by 0 and you will not, the repeats are not allowed. Okay, so basically you are forming a 6-digit number, 1, 2, 3, 4, 5, 6. Yeah, and we have always seen wherever there is a condition that we first satisfy, we'll try to satisfy that place first, then we'll look out for the other numbers. Like when we used to do even numbers and all that, that part we will satisfy first, then we will carry on with the other part. So since they have said that it should be divisible by 10, this place can be filled only by 0. You cannot fill it by any other number, but only by 0. So 0 will go there. There is no other choice for 0. So that place can be filled only in one way, by 0. So that place is gone. Now how many places are left? 1, 2, 3, 4, 5. 5 places, 5 choices. 5p5 ways, 5 factorial. Answer 5 factorial. Clear? That's it. Whenever we don't want repetition, it's p that we take care of, and p is 5p5. 5 places, 5 choices. So 5p5 ways. That's all about the answer of this problem. So let's kind of write it in detail. Here the required number has to be divisible by 10. So one's place is occupied by 0 alone in one way. Just happening only in one way. Then there are 5 places and 5 digits to fill it. Therefore, number of ways of doing it. Is 5p5, which we know is 5 factorial, and somewhere we had memorized that 5 factorial is 120. So the total number of forming this kind of a word is 120. Pretty simple after those heavy questions. Yeah. Quickly we can take the 6th problem. Let's see what it says. The English alphabet. Oh, this is like the first problem. I don't know whether you remember the first problem where we did the choices, we kept the things ready, then we arranged them, then we formed a word. It was a problem with permutation and combination coming together. This is that kind of a problem. The English alphabet has 5 vowels and 21 consonants. It's there. How many words with 2 different vowels and 2 different consonants can be formed from the alphabet? How many words? Yeah. So the English alphabet has got 5 vowels and 21 consonants. From there you have to pick 2 vowels, you have to pick 2 consonants. So you would have picked it up and you would have kept it aside. Now picking and keeping it aside doesn't form the word. So you have to now form the word. You have got these 4 alphabets with you. I would have chosen, if you would ask me, maybe I would have chosen A, E and maybe B, D. Suppose say if A, E, B, D, these are the 4 alphabets available with me, then I can put them in different ways. A, E, B, D, B, E, D, A, D, B, D, that way, many ways of doing it. So that has to be accounted for. So that is our line of working. So we have intelligently broken up the problem. First choose the vowels, then select the consonants. Having selected it, you have to form the word. How many ways you can form the word? Then multiply them all together. That will give you the answer. So vowel selection. 2 vowels here. 2 vowels are selected from 5 vowels. Therefore, number of ways is 5C2. I wonder whether we should do it here or at the last. I think at the last should be better. 5 factorial by 2 factorial into 3 factorial. Then 2 consonants from 21 has to be selected. So number of ways of doing that also is 21C2. 21 factorial, 2 factorial, 19 factorial, n c r n factorial by r factorial, 21 factorial, n factorial by r factorial into n minus r factorial. Now, having got 2 vowels and 2 consonants, they have to be arranged to form a word. So 4 places and 4 choices. So number of ways is 4p4, which is 4 factorial. Right. So number of ways of forming the word. Finally, we have all this mn. One thing, all brought together. So 5 factorial by 2 factorial into 3 factorial, vowel selection, consonant selection, then word formation. I have to borrow this place. So this will come to 3 factorial into 4 into 5, 2 factorial and 3 factorial. 2 factorial is 2 itself, 3 factorial, and 19 into factorial into 20 into 21, and 2 factorial is 2 itself, 4 factorial, I don't know, 2, 3, 4. Okay, 3 gone, 3 factorial gone, 19 factorial also gone. Okay, 2 2s are 4, let it go. So what are we left with? 5 into 4, 20, 20 into 20, it is 400. So 400 into 6, 2400. Right. So it is all about 21 into 24. 4 1s are 4, 4 2s are 8. Then 2 1s are 2, 2 2s are 4. So 4, 10. Oh, this I was just talking about this 504. 50400. Yeah. In so many ways you can form this word. That's about this. With the remaining problem, we are coming in the next video. Thank you.